In our next section, we're going to look at the configuration examples of BGP confederations, and we'll see one of the big requirements of this versus doing a route reflection is that this is a disruptive change, and from a design point of view, it's something that you need to plan in advance before you get to the point where you realize that you need confederation, because it means that you would have to pull off the previous BGP peers and then to reconfigure them. Now, specifically, confederation is going to be a three-step process in configuration. We turn the BGP process on by specifying the sub-AS. We then tell the BGP process that it's running confederation and what the actual autonomous system is, and then we specify who are we peering with that is part of the confederation. Now again, the disruptive portion of this is that you cannot change the BGP AS once it is configured. You have to deallocate the process and then you have to reallocate it. So this means that either in a real design or within the scope of the lab exam, if you don't realize that you want confederation and then you need to come back later and do it, it's a disruptive change, where you would have to undo your current configuration and then you would have to reapply it with the new BGP AS. So for example, on router 10, if I were to say router BGP 100, and here it says we're already running BGP, it's in AS 10. Even if this was a private AS number, if we said 65010, it's not going to allow us to do that, because we can only have one global BGP process. This is different than IGP, where IGP can have multiple processes at the same time. So make sure that you plan out your design within the scope of the exam. This means that you need to read ahead. So look at the overall design of BGP, figure out what's the final goal that they're trying to get you to, and if that involves confederation, you need to do it from the get-go. Now in this case, when we look at the devices that are outside of the AS, and that we're peering in, which specifically were router 9 in AS9 and router 10 in AS10, they are peering with what they think is AS100. Now, from the confederation point of view, this is only locally significant in terms of configuration. So once this is complete, router 9 and router 10 are not going to know that AS100 is running a confederation. Specifically, the reason why is that we're hiding that when we actually go to exchange the AS path by using the main autonomous system for the true eBGP neighbors as opposed to the sub-autonomous system numbers. So let's say we're going to break our main, we're going to break our main autonomous system, which is 100 here. We're going to break it into multiple sub-ASs. And let's say here that we're going to follow the physical topology, where we're going to have router 2 just be in its own AS. Let's say we have 65002 over here. And let's say that between router 4 and router 5, and actually router 9 is, router 8. Let's say we have these three, and these are going to be in 65458. And then we're going to have these four be in 65,000. Now, technically, you don't need to use the sub-AS numbers, or you don't need to use the private AS numbers. You can use whatever you want. But the issue is that if you use some actual value, like let's say you use AS1 as part of your confederation, it means that if you receive an actual path that has one in the update, then the router is going to discard it. So the idea is that normally, since these don't route out onto the internet anyways, if you look at the global table and you parse for that range, 65, 4, 512, whatever it is, and up, you shouldn't find any that are actually in that range. So it's just a locally significant value, just like you could use RFC 1918 space. So then let's go ahead and first start the process. So let's start here on router 7, which is going to be peering with router 9. So on router 7, we're going to start a new BGP AS. And we're going to say that it is BGP 65,000. Okay, next we're going to specify what is the BGP confederation identifier. So this is the global autonomous system number, and you can see here it gives it either to you in the 2-byte format or the 4-byte format. So in our case, we're using a 2-byte AS. We could also say 0.100, which is technically the same as just 100. Depends on the particular version or not. Like in this case, this particular version, I don't believe is going to allow you to say 0.100. but technically it means the same thing. So that's our main AS is AS100, and then we would need to specify who are our confederation peers. Now the confederation peers are going to depend on what does the rest of the topology look like and who do we actually have the peerings between. So let's now say that we're not peering directly between everyone. So we're going to have these four here that are in 65,000. We have router 2 that is in 65,002. And then we have 4, 5, and 8 that are in 65, 4, 5, 8. Now on the interconfederation edge, so let's say that we peer between 2 and 5, we peer between 2 and 3, and we peer between 2 and 1. In this particular case, they would need to specify each other as confederation peers because the process doesn't automatically assume that a private AS number means it's a confederation number. So if in the case here, like on router 7, if we don't have any peers that are interconfederation, you don't need to issue that command. Now, it's not really going to hurt. You could go to all 8 of the routers and say BGP confederation peers 65,000, 65,002, 65,458. It's not going to hurt anything, but it's not really going to accomplish anything either. So next on router 7, we don't need to issue then the BGP confederation peers. We just need to issue the regular neighbor statement. So let's say neighbor 155.179.9 is in AS 9. And if we show IPBGP summary and the peer comes up, then we know there's not an issue with the AS number for the capabilities exchange. Now this would be different, for example, if we were to go to router 8, and let's do this on router 8. So let's go to global and say router BGP 65.458, and the neighbor we'll say is 155.1.108.10, who is in remote AS 10. And then if we look at on 8 and 10, we should get a syslog message saying that there was a BGP notification. BGP notification means there's something wrong with the particular peering. Now also here you can see in this notification it says the peer is in the wrong AS. If we look at here it says FFB2, and it's constantly going to dump this log over and over and over, but FFB2, if we were to look at this in our calculator, and let's look at this in hex, so it's FFB2 in decimal is 65,458. That's what the first peer is trying to send in the open message. So if we were to actually capture this and look at the packet format, they do, of course, exchange what the AS number is. And in this particular case, it's the wrong one. It's the private AS when it's supposed to be the public AS because we didn't issue the confederation identifier. So essentially, everyone that participates in the confederation needs to issue the second command, which is the BGP confederation ID. But the BGP confederation peers, again, only needs to be on the people who are actually doing the confed eBGP peering. So if we go to router 8 and let's say under BGP, BGP 65458, BGP confed ID is 100. We can see now the peer is up. So if we look at the show IPBGP, we see that we're learning the routes from the eBGP neighbors. If we were now to do some advertisement, so let's say that we do this on the edge again, which if we show IP route EHRP, we see we have our internal loopbacks. And let's say that we're just going to advertise these into BGP. So we say router BGP and then whatever the AS is, in this case 65458. We're going to have network statements for these. And again, with the network statement in BGP, we have to tell it the exact mask. And then we have one more, which is 151.88. So let's go to router 8, and then we'll originate the networks. Now again, we'll talk about this in more detail later under the NLRI section, But the basic requirement for this is that as long as you have the route in the routing table, you can originate the prefix. So even though these loopbacks are not directly connected to 8, that's okay because it has IGP routes to get there. So we could do the origination on each of them individually, but it doesn't really matter. It's the same effect as doing it on the edge. But if we were to now go to router 10 and let's look at the show IPBGP, we see that we are learning those loopbacks from them, but the key is that the path does not include the sub-AS. So we're basically spoofing it by removing it and then replacing it with whatever the actual confederation identifier is. Okay, so next let's go ahead and set up the rest of the sub-ASs. So let's say that we have 8 is going to pair with 5, and then 5 is going to pair with 4. And we're going to do this just based on the physical topology. So let's say on 8 that we're going to go to router BGP 65458, and we're going to pair with 155.158.5 in the same AS, 65.458. Yeah, I don't need to say the update source because they're coming from that directly connected link. And then router 5 is going to pair with 4. So we'll say, same thing, router BGP 65.458. My BGP confed ID is 100. My neighbors are router 4, who's in the same AS, 458, and also 58.8. Okay, one of those pairs is up. Now let's do the same thing on router 4. BGP confed ID, and then 100, and then the neighbor. Remote AS. And keep in mind here that we're pointing them at the sub-ASs, not the global AS. It's only the device that is outside of the confederation completely that would reference them with their public number. So inside the confed, we see the confed sub-ASs. Outside of it, we don't. Okay, next we can see the peering is up. So let's look at what's the state of the current advertisements. So right now from router 8's point of view, it should be learning prefixes from 10. So if we go to 8 and we look at the show IPBGP, and let's look at just our external route. So again, we'll say regex caret 0 through 9, close bracket, plus. Okay, so these are the external routes. We should be advertising them to router 5. So if we show IPBGP neighbor 155.158.5 advertised routes, okay, we are advertising the prefixes to them. Okay, next we go to router 5 and we look at the same thing. So let's show IPBGP for those routes. Okay, we're learning them. If we show IPBGP summary, we see that we're peering with router 4. If we show IPBGP neighbor 155.145.4 advertised routes, this prefix is a 0. So 10 is advertising the routes to 8, 8 is advertising them to 5, but 5 right now is not advertising them to 4. What would be the case here? Why would 5 not advertise the route to 4 even though it's valid? So we can see here the key point on router 5 is that it is a best route. So it does have the greater than sign. It means that we know how to get to the next hop and that we should be able to install it in the RIB. If we show IP route BGP, from our perspective, there's nothing wrong with these routes. If we ping 150.199 and source this from our own loopback, we should be able to get there. But when we look at our next neighbor within the confederation, we can't do advertisements. And again, the reason why is that the full mesh rule still applies within the sub-AS. So either we would have to make router 5 a route reflector, or we would have to do a full mesh. So it's only changing the behavior when we're looking at inter-confederation or inter-sub-AS communication. So for example, if we look at router 2, so let's add router 2 to the network. We're going to make it 65,002. And on router 5, we're going to say under BGP 65458, the BGP confederation peers, and actually let me leave that off for now. Let's just say neighbor 155.102 is in remote AS 65,002. And on router 2, let's do this. Router BGP 65,002. Neighbor 155.105, remote AS 65458. It says the peer is in the wrong AS. Now they're giving us a notification that's saying they're in AS 0064. Well, 0064 in decimal is 100. So what does this mean? Okay, on router 10, we had it the other way around, where router 10 was peering with the global AS, and then we were advertising it the wrong one. We were advertising it the sub AS. In this case, I'm peering with the sub AS, and it's trying to give us the main AS. The reason why is that 5 and 2, they don't know they're part of the same confederation. And this is where the application of that command is. So on router 5, we need to say that the BGP confederation peers includes 65,002. So for that direct eBGP neighbor, and now we can see the peering is up. So for that direct eBGP neighbor, when I go to send them my basically open message, they know that they're in that AS. Now, from router 2's perspective, we still have a problem here. It says invalid AS was received from a non-confederation peer. This is because I'm still missing one of the commands, which is, well, actually, it's two of the commands. One is that we need to say the BGP confed ID is 100, and the BGP confed peers are 65,458, because basically router 5 is trying to insert those other confed attributes, the confed AS and the confed set. That's how router 2 knows that router 5 is trying to be in confederation, but something's misconfigured. So assuming that logging is not off, then you should be able to figure out what this problem is. That it clearly tells you that there is a malformatted message. Specifically, the reason why is this very last byte, that's the AS. The AS was wrong. Okay, this message is even more obvious. It says the notification was sent because the peer's in the wrong AS. Then here we have the misconfig because we're missing the confed ID or confed peers. It says we got an AS path that is trying to be a confed AS set, but we're not configured with them as a confederation peer. So again, if you do get confused for some reason and you don't know exactly where you're supposed to put the confed peers command, you can put it everywhere. It doesn't really matter. It's just that if it's not on the routers that need it, then it's not going to work. But within the scope of the lab exam, if they don't tell you use the minimum commands or something like that, then there's nothing wrong with doing the config. It doesn't help you, but again, it doesn't hurt you because you're not directly peering with that AS to begin with. But if we now look at router 2 and show IPBGP, we should be able to receive the updates. And let's show IPBGP summary. The peer is up. Show IPBGP summary. Let's do this. Clear IPBGP star out. And show run section BGP. We should be able to, there we go. Okay, so now we're learning the routes. Sometimes you'll see the process gets hung like this. If for some reason it's not advertising, just do a route refresh out, and then that should push the new policy. The reason was that it's basically an order of operations issue, that they tried to send the updates, but then they couldn't, so router 5 doesn't automatically refresh them again. If we waited maybe a half an hour, it probably would work itself out. But anytime you need to force a triggered update, just say clear IPBGP out or in. If that doesn't work, then you can do a hard clear. Say clear IPBGP star. But again, don't do that in production. In the lab exam, it's fine. But in the production, very, very bad to do that. Okay, so now in router 2, if we look at show IP BGP, notice what's different here is the confed AS is now part of the path. But it listed here specifically inside parentheses, so we know that this is part of the confed set. Now, if we wanted to match this specifically to say, what are the routes that are coming from our confed peers, you can match the literal characters open and close parentheses in the AS set, and then you're going to know that those routes come from the confed peers. So I'll show an example of this once we actually build the rest of the peerings. But you can use the regex to search for whatever you want. It's just that you would have to match the literal characters open and close parentheses, and then that means it's part of the confed set. Okay, so next let's go to router 5, and we're going to need to make another change. We would either need to, again, fully mesh 4, 5, and 8, so we could add a peering between 8 and 4, or we would need to configure router 5 as a reflector. Now, this is also one of the common reasons that in most real designs people don't use confederation. Because if you're going to have to use route reflection anyways, why not just use reflection? Why add the extra complexity of confederation on top of it? So it does add an extra layer of policy application when you're looking at the confed eBGP peers versus just inter-cluster peering between route reflectors. But at least in my personal opinion, I would say it's just overcomplicating the design. So they do the same thing, either separate them so that they're all in their own sub-AS, and then you treat everything as eBGP peers, or just use route reflection, and then it should accomplish the same goal. Okay, so we're peering between 2 and 5. We then need to go to 5, and we're going to set 4 as a route reflector client. So let's say under BGP 100, neighbor, actually the sub-AS, 65.458. Neighbor 155.145.4 is a route reflector client. Okay, they should flap the peer. They do a new capabilities exchange. And then if we show IPBGP on router 4, show IPBGP, now we can get the routes. Okay, next we're going to peer over to 1, 3, 6, and 7. So they're going to need to say, first off, router BGP 65,000. The BGP confed ID is 100. And only on the edge, so only on 1 and 3, would we need to set what the confed peers are. But again, it's not really going to hurt anything, so let's just add it in there. Let's say BGP confed peers is 65,002 and 65,458. Okay, so this is on 1, 3, 6, and 7. So on 1, 3, 6, and 7. Now for these ones, I'm going to do a full mesh peering. And the reason why is that we're going to see a little bit of a difference here when we do the full mesh based on the visibility of different prefixes versus doing the reflection. Because remember, the reflection hides the topology by the reflector only chooses one best path and only reflects that on. Now, we will see that there are some alternate behaviors that we can add later, like BGP add path, but by default, you don't do that. Normally, you only choose one best path and can you continue to advertise it on. So for the rest of these, we're going to say this. We're going to say we have the neighbors. Neighbors are 150.111, who is in AS 65,000. And the update source is loopback 0. And that's it. But we're going to say this. We need to say this 4 times. We're going to say it for 3.3 and 6.6 and 7.7. And again, the one that's duplicate here, it's just going to get rejected. So it's not wrong to put this in. The parser knows that it's not valid for itself to be a peer. Okay, next we're going to peer on the edge. So we're going to peer from 3 to 2, and from 1 to 2, and then router 5 as well. So from 3, we're going to say router BGP 65,000, neighbor router 2, 155, or actually let me use those connected links. Let's say 155.1.23.2 is an AS 65002. 2 is going to do the same thing on the way back. $65,000. Then we already have 2 and 5 peering. We need to have 3 and 5. What does this mean here? It says BGP notification sent to the neighbor. The peer is in the wrong AS. Okay, this means the peer is telling us they are in 100. We are telling them they're in 65,002. So why would router 2 and router 3 not agree on this here? It's because 2 is delivering the public AS, which means it doesn't know that router 3 is part of the confederation. And the reason why is that I only added the confederation peers for one of these sub-ASs so far. So I would need to say my confederation peers are not only this one, but also 65,000. You put all of this in one line. Okay, so on router 5, when we show run section BGP, we're going to need to say the confederation peers are 65,002 and then also 65,000. Okay, they're going to peer with routers 1 and 3. Then 1 and 3 are going to peer back to 5. 458. And then on 3. Okay, then we need our actual eBGP peering, which is going to be between 7 and 9. So 7 is going to say that the neighbor is 155.179.9, who is in AS 9. And then we should learn our actual transit prefixes. Okay, let's also do that advertisement on the edge for all of the internal space. Now again, we could do this on every router, but you don't necessarily need to. You really only need to do this on the edge typically in order to originate the internal network space on behalf of the internal network. Now the other advantage of doing this is it's a central point of policy control. That if I want to influence path selection or how I'm advertising these prefixes, I only need to do it on router 7 and router 8 now, as opposed to doing it on all of the internal routers. So in general, you use IGP to route internally, BGP at the edge, and then the edge controls the routing policy on behalf of the internal network. The only time you need to run BGP in the middle is if you're transiting the global table and you're not running MPLS. But in most cases, that's not true. Normally, in most designs, only the edge routers will run BGP. Okay, so let's show IPBGP. Now we're learning the external routes. Okay, we can also see that we have a couple different paths here. We have a path that goes through router 2, and then it goes to 65.458, and then it goes to whatever the final destination is. This is the one that we're currently choosing as the best path. Now notice what's kind of interesting about here from router 7's perspective, we're saying we have 2 different ways to get to this prefix, and let's look at this in detail. If we show IPBGP for 151.10.10, it says there's 2 different possible ways to get there. One of them is internal to the confederation. One of them is an external route. Now, normally, an external route is preferred over an internal, but that's actually not where we're making the selection here. We're actually making the selection based on the AS path. Now, what you would assume here, though, is that the confed path should be longer because we're looking at 3 ASs versus 2. But in this case, the internal length doesn't matter. So it's counting the whole entire confed as 1 instead of counting it as individual ones. Now we could see that this is the actual case, why it's choosing one over the other. If we were to do this, let's say that we go to 10 and we configure this. Let's say route map X, set AS path prepend 10, 10, 10. And then as we go to BGP and advertise the updates out to router 8, we'll say route map X outbound and clear IP BGP star out. Once this update finally propagates, we could see now the confed path got deleted. So previously the confed path counted as shorter, even though technically there were more numbers in the AS. But it understands that it's not really external BGP. It's confederation external, which also doesn't modify the other attributes. So for now, let's go ahead and remove that config. So we don't want to prepend. We want to see just what would happen under the normal cases where we're not modifying any path selection. So let's look at first off, make sure that all of the peers are actually up. So on every router, let's look at the show IP BGP summary. And we want to make sure that none of these say idle or none of them say active, anything like that. And here we're looking at in the state on the right. Okay, it looks like all of the peers are up everywhere. So now let's look at specifically how an update is getting advertised in. So let's start with the updates that are coming in from 10. And let's look at how they get advertised when they get to 8. So router 8 says I only have two peers. I have my confed internal peer and I have my eBGP peer. So if we show IP BGP neighbor 155.158.5 and look at the advertised routes, we see that we're reflecting back to them the loopbacks, but notice here the next hop is itself, which looks like it should be a loop, but it's really not, because I'm giving you the route via iBGP, and you have a route to get there through IGP, so you're not going to use the BGP route. Okay, we should see on the reflector this counts as RIB failure, but it is still allowed to reflect them because the default is no BGP suppress inactive. Okay, when we actually go to route the traffic though, we're not routing through 8, we're routing through 5. So if I ping 150.111, BGP doesn't have anything to do with that. And we could tell this because when we show IP route for 150.111, we're always choosing the internal IGP distance versus BGP, versus iBGP. Okay, the rest of the prefixes, we see that we're advertising the actual external routes. So we're advertising the routes that came from AS10, they get to router 5. Okay, router 5 says, first off, these routes from AS10, they came from my confed internal peer. So notice that for these ones here, they didn't get the AS path updated. Now inside here, the next hop is still router 10 because we don't modify the next hop when we go from eBGP peers to internal BGP peers or external peers to confed external peers. So what this means is that if we look at this route anywhere in the network, the next hop still should be 108.10, which is okay though because we're already advertising that prefix into IGP. And we'll see a little bit later why you would want to do that. You don't want to change the next hop because it has an implication on fast convergence of BGP. But the route is getting advertised to router 5. 5 says it's a valid route, but it has RIB failure, but we can still advertise it on. So let's say like this one, for example. Okay, we learn it from the internal peer. Let's say show IP BGP 151.10.10. It says it's a confed internal peer, and we're advertising it to two separate update groups. Now, from router 5's perspective, we have two different types of peers. We have router 4 as a route reflector client, and we have routers 1, 3, and 2 as confed external peers. This is why router 5 is automatically grouping these into two separate update groups. Because basically when it generates the update, there's a difference in the AS path information when it's going to 1, 2, and 3 versus when it's going to 4. But the point is that this is happening automatically. You don't have to manually put them in peer groups. You don't have to worry about the policy application. The router automatically figures out when I send the update, which can I just replicate it to multiple peers versus making 4 separate path selection decisions. So it's basically an automatic optimization here. Okay, so let's see on router 5, who are the peers and are we advertising it on? If we show IP BGP neighbor, 155.101 advertised routes, and let's just look at that one particular prefix. Pipe include 150.1.10.10/32. Okay, it is getting advertised. We should also be advertising it to 2. We should be advertising it to 3. And we should be reflecting it to 4. So these are 2 separate advertisements, the one that is going to 45.4 versus the one that's going to the Confed E BGP peers. So these ones here, these would be allowed automatically. The last one is only allowed because I made router 5 a route reflector. Now somebody had asked here, is it a recommended design to do this? There's no real wrong way to do it. The ultimate goal is to get the updates to propagate everywhere. As long as you can get the update there, then normally the BGP design doesn't even really matter because BGP is not being used to forward the traffic. Now we'll see there are other cases that if we're doing like next hop modification, then the BGP design does become an issue. Because I might want the traffic to go that way and it's actually going the other way because I'm doing some modification of who is actually supposed to be, who is the traffic supposed to be forwarded towards. But in this type of scope internally, it doesn't really matter. The end result of full mesh, of route reflection or confederation should ultimately be pretty close, just that you get the updates everywhere. The main difference again will be how many updates do you get. So if you have full mesh, you would get the most updates, but the advantage of that is you have full visibility. So you know all egress points out of the Confed sub-AS and also out of the full public AS. For route reflection here, router 4 is only going to see one exit point for all of these routes. It's going to be whatever router 5 chose as the best path. So we should be able to see that if we look at what's the difference between 5's view of the table versus 4's view. 4's view of the table should be much more limited because it only has the best paths that router 5 reflected on. Now notice what didn't change though. The next hop value is not changing, which means that router 5 does not necessarily need to be in the data plane. So as long as it can reflect a pretty good view of what it assumes people should be routing through, the end result might be the same as doing full mesh IBGP. But when we look at the difference between the control plane load, if this is a full view of the table and we have to take it 3 different times, then it's going to be much more overhead to run full table 3 times versus the full table just once. Okay, so now router 5 should advertise the route to 1, 2, and 3. Let's look at from everyone's perspective now. The show IP BGP 151.10.10/32. And mainly we want to look at here who has multiple paths to this and who does not. So if we look at router 2 does have multiple routes. It says I could go directly to 65.458. I learned the update from router 5. That's router 5's router ID. This is the peer address that I learned it from. And this is the next hop. Next hop is 108.10. So then I would use my IGB metric to the next hop in order to actually get there, depending on the other attributes. So it turns out to be that one of them here, this one is chosen as best. Let's see, why is the last route here chosen as the best route? Which is kind of strange here because notice that this one has 2 sub-ASs in the path. The first one only has 1 sub-AS in the path, but the second one is still being chosen as the best route. So let's actually go to the path selection decision. Let's look at the page. if you just search for BGP best path, it's the best path selection algorithm, and what we need to do is to get down into where it says the decision relates to confederations. Okay, so actually before I do this, let's go through the list. First, I have to make sure everything is equal. Okay, the first one is the weight. Right now, neither of these are weighted. We should see it listed on one of these lines, but we don't, so it means the weight is 0. Then we have the local pref. Both of the local preference is 100, so it's not that. Then we look for local routes. So neither of them are actually advertising the route, so they're both equal. Then we look at the AS path. In this case, the AS path is different. So this one looks like it should be shorter, but the end result is not. Okay, they both count as a length of 2 because the entire confed set counts as 1. So they're both a length of 2. Then we look at the origin code. Both of them is origin code IGP. Then we look at the med value. Med value is 0 in both. Then we look at the external over internal. Both of these are confed external. Then we look at the IGP metric to the next hop. In this case, both is the same. Now we're somewhere down into the tiebreakers. And I want to say that it's going to be based on this, that it's based on the router ID. So let's actually look down in there in the decision. So it says, prefer the shortest AS path, but note that confed sequence and confed set are not included in the length. Okay, and AS set counts as 1 no matter how many ASs are in the path. So basically these count as equal regardless. Then the lowest origin code, then the lowest med, but notice here it says that med confed is ignored. So you can also say BGP best path med confed, which we're going to come back through these in detail later. So for now, that's the default is off. Then we look at so more about med. Okay, it says paths that contain the AS confed sequence and confed set are local to the confederation. Therefore, these are treated as internal paths. There's no distinction between confed external and confed internal. And then prefer the path with the lowest IGP metric to the next hop. Continue even if the best path is selected. You could now do multipath. Okay, right now multipath is not enabled. So if we show IP route for 151.10.10, we can only install one route. But if we were to go to the BGP process and say BGP, or is it just maximum paths? Maximum paths for, let's just say 10. I'm not 100% sure if that's going to take confed as well. Router BGP 6500, maximum paths 65002. Maximum paths for EIBGP, so both of them, let's say 10. That should include everything. Deconfigure eBGP multipath first. Okay, this I'll come back to in more detail later as well. This may cause a loop because the command is accepted. Let's say clear IPBGP star in. Clear IP route star. I don't know if it's going to allow us actually to do multipath on different routes that come from different confed peers. But let's say, okay, so what comes after this? So when both paths are external, prefer the path that was received first. Okay, this is not the case. These are considered to be internal. Then it says, if you have BGP best path compare router ID, then prefer the one that comes from the lower router ID, which is, I think, what the case is now. So let's do this. Let's go to router 3 and say router BGP 65000, BGP router ID is 151.33.33. Then if we look at on router 2, let's see if we're going to relearn the path. We actually may not relearn the path. It depends on who is making the path selection decision now. Someone had asked, why would it do this if we didn't compare router IDs? I thought it did by default. Let's see if it's going to get the path back in. Yeah, it is. That's what the decision is. Right now it's based on the router ID. Because the only thing that I changed was now this one is higher, and now the best path moves to router 5. So you can end up in these interesting situations where you think you're going to go one way and you end up going the other way, simply because the path selection process is so complicated. Now, if we ultimately want to affect the traffic flows, there's really easy ways to do that. Just by setting the local preference as we send the update in to the confed or into the internal network, that should always be preferred. Preferred as the, or I should say, used as the preferred exit point. But when you look at just the default parameters, then it starts to become a little bit complicated. Someone else said, I agree, but the other one is the older route, which is technically true. So let's do this. Let's say on router 2, show IPBGP summary, clear IPBGP 155.105. This is going to flush 5's route out. Let's see when it comes back in, if the route is chosen as Beth from 5, then it's not the route age is the issue. Because I flapped the pier went down, the pier comes back, then it's still choosing 5 as the best path. So it's not the age. In this case, the age is only on the age is on the eBGP routes, not on the iBGP routes. Which makes sense if you look at what the document is saying, is basically that whatever is the older route is the one that is stable. So if you have some route that's flapping, but for some reason it has a better attribute, you would still be better off choosing the older one because it means that it's the more stable path to get there. Someone had said, I think this is based on the lower neighbor address. That actually could be true because it says prefer the path with the lowest neighbor address. Well, let's look at this. What are the two different peers? 155.105. Let's do this. Let's say on gig 123. Let's say the show run pipe include 23 or BGP. Let's do this then. And this is kind of the point that once we get into the tiebreakers, it is difficult to figure out exactly where the path selection is happening. So when you're actually trying this out on your own, just change these parameters around and see what the ultimate result is. So what I'm going to do here is change the address here. I'm just going to move it down 1 octet to see if this is actually the result. That may be the case then. And so let's say this on 2. And then on router 3, also we need to say this, router BGP or router EIGRP A, address family IPv4 AS1, network 154. Because they still need to be IGP adjacent here. Let's say show run include 23 or BGP. So what was that? I just need to flip those two and then flip these two. And then it was under router EHRP A, IP address family IPv4 AS1, network 154. Okay, now the BGP neighbor is back up. Let's check on 2 what changed in the selection. It's still choosing 5. So the peering address is lower, but the router ID is lower. But which one does it say is actually supposed to? Well, let's do this. Let me turn this command on and see if it shows up in the config, because it's not under the default. And actually, it's something I showed here I hadn't talked about before. Is in this version you can say show run all, like show run all pipe section BGP, and this should show you all of the default and non-default options. But for whatever reason, compare router ID is not listed in here anyways. So let's say 65002 BGP compare. What is it supposed to be? BGP best. Compare router ID. Show run pipe include router ID. It was off by default, but notice it says here, compare the router ID for identical eBGP paths. That's not the case that we have here. But anyways, we're going to spend more time on path selection regardless later. The point being that even when you make your selection between the different sub-ASs, they don't control your routing policy. Because when we look at the final end result, like let's say from 6's point of view, and 6 says, how do I get to that particular prefix, the 151.10.10? Still, the IGP path to the egress next hop is ultimately controlling the traffic flow. So if we trace to 151.10.10 and source it from the loopback, regardless of how the best path selection is done, it's still up to IGP in order to actually do the forwarding. So even though the peering arrangements here are kind of strange, where 6 is peering with 1 and 2, and actually it should be receiving multiple routes, this must mean that somebody else is limiting the view. Like let's say on 1 and 3, 1 says to go to 5 and 3 says to go to 1. So for whatever reason, when the route comes from 5 to 1, 1 is saying this is best. Then it's going from 5 to 3 and from 1 to 3 because we're doing full mesh. 3 says that this is best, which means that this one is withdrawn and it cannot be advertised to 6. So in this case, 6 only sees one view because if 3 is routing through 1, then it can't advertise 1's route onto the destination or onto the router in this case because it's not a reflector. So you could see that the advertisement rules, they do get pretty complicated how this works here. It's just that if you take it's basically only 3 cases. If you learn the route from an eBGP neighbor, you can advertise it to anybody. Doesn't matter. If you learn it from an iBGP neighbor, you can only advertise it to another iBGP neighbor if they are a client of you, or if they're not a client of you, but you learn the route from a client. So either case, when you are a reflector and you have 2 iBGP peers, as long as one of them is a client, the updates will get exchanged between the both of them. The only issue that the route gets filtered out is when it's going between 2 non-clients, either on a route reflector or someone that's not configured for reflection. But again, even if you didn't remember this, there's an easy way to validate it, which is just to show IPBGP neighbor and look at whoever you're peering with, let's say 155, 105, and then look at the advertised routes, this ultimately is the final decision. Regardless of how you thought the best path selection was supposed to work, because again, remember that the process can get stuck or wedged where based on how the process loads, if I advertise my route to you before you get a chance to advertise your route to me, we might end up in a different view of the topology. And you could try that out. If you clear the table in different portions, you might see that we egress via router 10, and then all of a sudden we start egressing via router 9. And it really depends on whose path gets in there first, because ultimately BGP is normally about stability, not necessarily the ultimate best path routing. If you always want to choose the best path, then you want to do full IBGP mesh, which means again that you should learn all possible paths, but then the issue is that you have the control plane scaling problem. So let's recap the config here real quick. Let's say show run section BGP. On the true eBGP edge, we're going to peer with them in their regular external AS. They think that we are 100. We then have other neighbors who are in 65002 and 65458. In this particular case, I could delete this command on router 7 because it doesn't actually have a neighbor statement that directly points to them. Okay, the case that I do need this command is like here on router 1, or more specifically here on router 2, where router 2 is saying my confed ID is 65, or not my confed ID, my sub AS is 65002, but I'm also pairing with 65,000 and 458. I need to tell the process that these two are part of my confederation. Then everyone needs to agree on the identifier because that's ultimately what we put in the AS path outside. So again, from 9 and 10, if we show IPBGP, again, they don't know any of these details. They still see 100, and they're going to run their normal best path selection on that. Okay, the other key takeaways from this is that when you do the actual advertisements, the confederation is not updating the other attributes. Where the other attributes specifically that are important are the next hop value mainly, and then other things like the local preference or the med. But we will see that there are other steps in the path selection that do change when we're dealing with sub-ASs, and we'll come back to that in more detail. But unless you are manually modifying the next hop with next hop self or with a route map, regardless of how router 6 learns the update, the actual path selection is going to be based on that particular next hop or that particular next hop by default.